So, hello everyone, myself Akash Reddy from SPC College. Implement and demonstrate Q learning algorithm is the today's topic, and overall these topics will be coming under the advanced machine learning, deep learning concepts. So, let's look into the following topics, what and all we are going to be studying today. So, these are the contents. So, at first we have the introduction, next Q learning overview, Q table, basic Q learning algorithm of policy learning, Q learning example, convergence and optimality, and the last we have applications of Q learning. So next go on through the introduction of a Q learning. So the contents are introduction, Q learning overview, Q table, basics, Q learning algorithm of policy learning, and Q learning example, convergence and optimality, and applications of Q learning. So the first content is introduction. So reinforcement learning is an interdisciplinary area of an machine learning and optimal control considered with how an intelligent agent thought to take action in a dynamic environment in order to maximize the calculative reward. Basic components of the Q learning agent, environment, action, and rewards. A reinforcement learning model has four essential components: a policy, a reward, a value function, and an environmental model. So the second topic is Q learning overview. Explanation of a Q learning as a value-based reinforcement learning algorithm. Q learning is an model free of policy reinforcement learning that will find the best course of action given the current state of agent. Use of Q values to iteratively improve the behavior of the agent. Q learning uses Q values to represent the expected cumulative reward of taking a particular action in a particular state. So the third topic is Q table. Building a table of Q table consists of Q, S, and A values. A Q table is our lookup table where we calculate the maximum expected future reward from our action at each state. Installation and update of a Q value based on the agent experience. To learn each value of an Q table, we use a Q learning algorithm which involves an iterative process of updating the values based on the agent experience. So the next topic is basic Q learning algorithm. Description of a Q steps in a Q learning algorithm. Q learning algorithm is a model free reinforcement learning that learns the value of an action in a particular state. It doesn't require a model of an environment and can handle problem with a transaction and reward without a requiring adoption. Exploring and exploitation phases. A Q learning algorithm involves a basic balance between the exploration, trying a new action, and exploitation, choosing action based on a correct knowledge to find an optimal solution or a policy. So the next topic of policy learning. Explanation of a Q learning as a policy learning algorithm. Q learning takes an of policy approach to reinforcement learning, aiming to determine the optimal action based on its correct state. The agent ability to learn Q learn regardless of a policy being followed. Q learning allows the agent to learn values independently of the policy being followed, which contributes to its robustness and flexibility. Q learning example. Step-by-step instructions of a Q learning process in a simple environment. A Q learning example can demonstrate how an agent learns to make decisions based on a Q values associated with the different actions involved in various states. So there are 8 states basically: initialization, action selection, and Q value update. And the queue learning process involves initializing the queue table, selecting action, and updating queue values based on the rewards. And even the values involve a discussion on a convergence of a queue learning. Queue learning aims to converge to an optimal policy by iteratively updating a queue values based on agent experience on a reward and revised. The goal of maximizing the queue value to find the optimal action selection policy. The ultimate objective of a queue learning is to maximum the queue value for each step action pair to determine the optimal action selection policy. So the next topic and the last topic is applications of a queue learn. Real world application of a queue learning such as game playing on a robotic control. Queue learning has been successfully applied to various real world problems including games, playing, robotic controls and optimization tasks. Success stories of a challenges in applying a queue learning to complex problems. While queue learning has shown success in many domains, it also presents a challenges such as scalability to large state space and complex environment. And thank you. So these are the overall topics of a queue learning algorithm. So thank you.